This is the homework helper for Workbook 7-3, Triangles. Now, what's important here is that you remember that triangles, the angles of a triangle, have to sum to 180 degrees. If you come up with any number that's not 180, you've clearly done something wrong. So let's go ahead and take a look at just a few of these here. We won't do all of them because I think the concept is basic enough. So again, we're looking for 180 degrees. Well, if we take a look at question 1, what we have there is an X and a 49 and just an angle marking. Well, that angle marking there, as you recall, indicates 90 degrees. And it should be clear to see it does that angle that's marked with that upside down backwards L there. I'm sorry, the regular L there, it would appear on the screen, is going to be 90 degrees. So this is 90 and this is 49. So the question is, how many more do I need to get to 180? So if we're going to go into this, we're going to say 180 minus the 90 we already have, minus the 49 we already have, and that would get me 41 degrees. Okay, let's go ahead and take a look at another one here. Let's go look at number 7. Number 7 is kind of a thought-provoking question in that there's two angles missing there. And that would seem to be hard to do based on the fact that we know what all three would have to add up to, but we're missing two of them. There is nothing really fancy about this question, though, because the trick to this is that this is an isosceles triangle. Now, isosceles, you will recall, implies that two sides are equivalent. But what isosceles also implies is that two angles are forced to then be equivalent as well. And indeed, in this illustration, this side and this side would be the two equal sides, and those base angles then, the two that are kind of on the non-connected side, or the rather the non-congruent sides, non-congruent side set rather, on this side here, is the two angles that will be equivalent. So yes, we know this makes 180 all three together. We're going to subtract off the 64 we already have, which is going to give me 116, and then that 116 has to be split equally among those base angles there. Again, those angles are on the connected to the side that is not part of those two that are congruent. Okay, so I'm going to divide that 116 by 2 there, and that will get me my answer. And 116 divided by 2 should spit out an answer of 58. So each of those angles marked X is 58 degrees. Don't be fooled, you're going to use the same approach in question number 9, which, as you can see in the directions, is an isosceles triangle, but I'll leave you to do that one on your own. Let's look at 8. 8 is talking about an equilateral triangle. Remember, the term equilateral implies that all three sides are the same. Well, it also implies, when three sides are the same, that the three angles would also have to be the same. So I'm splitting the 180 degrees among those three angles equally. So really what I'm saying here is 180 degrees divided by 3, and that's of course going to be 60 degrees. Okay, let's go ahead and go to the bottom there. In the bottom, they're asking me to tell whether a triangle can have sides with the given lengths, and we are to explain. I'm going to do question 11 for you, but you can do 12 and 13 in the same manner on your own. Remember, what the book explains here is that any two sides I pick must be greater than the third side, or the remaining side. And if not, it would not be a triangle, at least not by these definitions. So we've got, start off with the 6 and the 8 here. Well, 6 and 8, when I add them up, makes 14. That is bigger than my other number, 13. So that set works. When I pick 6 and 13 here, 6 and 13, when I add those two up, make 19. That is not bigger than my remaining number, 8. So by definition here, this one is going to be a no. For the last one, I could check it. I don't need to because I already have the answer, but I would be adding 8 and 13, and that is, of course, bigger than the 6.